compound interest is used in finance and other situations in like banks and credit cards and all sorts of things like that, where you start to earn money on the interest that you have earned. So if we're talking like a bank account situation, you earn money on what you have in there. The bank would give you that money, put it into your account, and then you can start earning interest on that you just earned. With this, a lot of the times we are given the rates as an annual rate, but however, in our equations, because they're earning a portion of that, we need to figure out what the monthly or daily rate would be from that annual rate. So let's work through a problem with compound interest. We have a financial advisor recommends that a client deposits $7,500 into a real estate investment trust that earns 7.5% annual interest compounded monthly. And now we want to write our compounded exponential function that's going to model the amount of the account, the value of the account, as a function of t years. So let's start. We know they put in 7,500. So that is our initial amount, A0. We have also been given an annual interest rate. Our annual rate is 7.5%. We don't like using percents in our equation, so I need to get rid of the percent symbol. We can do that by dividing by 100. So that gives us 0.075. But now we know that it is compounded monthly. Which means we only want the portion of that annual rate that they would earn in that 1 month time period. This means we need to take our 0.075 and divide this by 12. And that gives us 0.00625. With these problems, sometimes we might want to leave this as a fraction, like how I had on the left here, if the decimal doesn't give us a nice decimal to work with. If it's something that keeps going on forever and we would have to round, that's going to cause errors later on in our answer, so we would want to keep the fraction format to make sure it's still exact. This one, however, the decimal stopped after just a couple of decimal places, so we can switch over to the decimal and not have to use the horrible fraction. Okay, so now we have these two pieces of information. We have our starting amount and our monthly rate. So let's go ahead and take that and put that into our formula over here on the left. So we have that the amount in the account is equal to 7,500 times 1 plus the 0.00625. And now I want to raise this to the t power for t being years. But let's make a note that 0.00625, our rate, that is for 1 month. And my t is for years. So if I remember, 1 year is 12 months, which means my t needs to get multiplied by 12 in the exponent. And now this final equation here, a equal to 7,500 times 1 plus 0.00625 raised to the t times 12, that would be my compound exponential function that represents this situation.